Yeah, so I don't know what the experience level of the crowd is, so I'm just going to give a very high level presentation about what Iroh is and how we use PKARR. And if somebody has more detailed questions, you can always ask. So let's see if I can. Hopefully this will work.
You should be able to share the screen, yeah.
Okay, so can you see this?
Yes, sir.
Okay. Okay, so Iroh and PKARR. First of all, what is Iroh in the first place? So this is the very technical definition. Iroh is a library for direct quick connections between nodes identified and encrypted using ED key pairs. And since this is a bit long, there's a little bit of a shortcut. So basically, Iroh is Quic, but P2P. So first of all, what is Quic? Depending on the audience, sometimes people know everything about it, sometimes nothing. So I'm going to explain a little bit what Quic is. So Quic is a transport layer network protocol that was designed by Google and is these days basically used by everybody. So a significant fraction of all traffic on the internet is Quic connections. And the connection that you're currently using with Google Meet is probably also Quic connections. So basically, Quic is kind of how the internet works these days. It is really very, very common everywhere. And a lot of work has gone into making Quic very useful. It is supported by all the major cloud providers and big companies. So not just Google, but Microsoft, Cloudflare, everybody basically. And also lots of use in China. And what's nice about Quic is that basically you could think, if you want to think about it in terms of TCP, it's like TCP over UDP. So basically, you take an unreliable datagram transport, actually an unreliable small datagram transport, because the UDP packets must not be larger than 1 MTU, and then you can have a very high-level system of streams on top of that. And that's quite attractive for browsers because they open lots of connections all the time, and you don't want to have multiple streams to one side blocking each other. So it has been kind of a little bit designed with Chrome in mind, but it's really a very general purpose transport protocol. And this is a bunch of the technical reasons why Quic is so cool. So what you get is you get very cheap streams, multiple streams per connection. If you're familiar with libraries that came kind of before Quic, like P2P, they have their own stream multiplexing. So that's basically trying to get multiple streams on one stream. And with Quic, that's kind of built in. And encryption is just delegated to TLS. So the encryption is just IETF standard. You got protocol negotiation built into TLS. You got congestion control and reliable delivery, meaning that if you have packet loss, the packets will be resent, and as a high-level application developer, you don't even notice. You got something called a zero RTT handshake, meaning that you can do an interaction where user data flows even in the first interaction, which is basically as good as with raw UDP packets. And you got a bunch of other very technical things which are quite cool. Okay, so this was a little bit technical. So first of all, let's say who's using Iroh at this point. So we got lots of users. This is Delta Chat. It is an application, a chat application that uses email as the back channel. And as you can see, which is notable about this, is it is available on all the major platforms, and it has Iroh kind of built in. So Iroh is a library which can be linked into Android applications or iOS applications or Windows or whatever applications. So, and also very notable, it is lightweight enough that it can be used on a mobile operating system without the operating system complaining, which is not always the case with peer-to-peer stuff. Okay, this is Rave. It is a a way where you can basically watch a show together with your girlfriend that lives in the next city or something like that. It's also available on all major platforms. This is a file system explorer, a file manager, and this is kind of a back-end application. This is distributed ML training. So you have kind of a distributed swarm of people with GPUs that can all participate in an AI training run. This is quite cool, but it's more like a back-end application. And we also have an awesome list where you can see all the people using Iroh. It's quite a few people. Okay, now I said Iroh is peer-to-peer Quic. So what exactly is the difference between Quic, normal Quic, and peer-to-peer Quic? So there's basically two things. One thing, we connect to the other nodes not by their IP address or IP address and port, but by their node ID. What's the node ID? It's an ID key. So basically, we want to know who we are talking about, who we're talking to, not where they are. We don't care where they are. We just want to talk to them. So this is the classical example. Alice wants to talk to Bob. Alice does not really care where Bob is. She just wants to talk to Bob. And Alice and Bob are identified by a ID key. And this is how it normally works with TLS. Alice has a key pair, but you can only talk to a server, not to Bob. And the server has a location. And so you address the server by the location, by the IP address and port. And then there's an entire certificate chain to make sure that you're talking to the right entity. And obviously, this is not peer-to-peer. This is not what we want to do. So fortunately, there is a new RFC, which is called Raw Public Keys in TLS. And so this is how Iroh connections work as far as the encryption is concerned. Alice and Bob talk directly to each other by identified by node ID. And the TLS connection is encrypted directly with these keys, which is now possible due to this rather new RFC. Okay, this is the one thing. So we want to dial by node ID instead of dial by socket. And then the next thing that we want to provide is, this is a very sad situation that we have these days very frequently. So you got two people that might be in the same room or in the same city, and they cannot directly talk to each other at all. The only thing they can do is they can log into Slack or Discord or whatever on the server in the US, and then they can talk to each other. And this is not what we want. So we have something called an Iroh relay. An Iroh relay has two purposes. One, it is a fallback kind of if direct communication is not possible, which is sometimes the case. And the other thing is the Iroh relay can help with something called hole punching, which means it can help these two devices establish a direct connection. So basically, this is a process where you do something, you need some coordination to do something at the same time, and then you can trick these two routers into thinking that this is a valid connection and letting the connection through. So the end result is that you have a direct connection between the two nodes, even though they are both behind a nut. So this is called hole punching, and there's different approaches for hole punching. We have a little bit conservative approach where we say we want to have relays which help with the hole punching, which makes the rate of hole punching higher, and also it gives you a fallback in case the hole punching does not work, which can happen in some very badly configured corporate networks. Anyway, okay, so now where's the PKARR? We have a large number of relays. We ourselves operate 10 relays or something, and then there's lots of our users that operate their own relay networks. So if Alice wants to talk to Bob, she needs to know on which relay Bob is. So a node usually goes on the relay which is the closest in terms of ping time. And so we need to publish this. Bob needs to publish the information on which relay he currently is in order for Alice to be able to call him. So what we need is we need some kind of free global registry. It can be, well, it could be cheap, but free would be ideal. And this registry needs to be updated quickly. So we cannot have something where you need a day to update this registry, because well, these things might change quickly. Like if you enable your VPN, suddenly you're going to switch to another relay, or if you fly on an airplane to a different geographic location, you will also end up on a different relay. So this information needs to be up to date. So PKARR or PKARR, whatever you want to call it, you know this. Basically, the idea is you need something like DNS, but you don't want to pay AWS or whoever to store DNS records for you. So it is basically just you take DNS records and put them on the mainline DHT. And the mainline DHT has a very nice extension called BP44, which allows you to store some tiny bit of information for an ED key pair. And since we're using ED key pairs, it's perfect. And so this is basically how it works. Bob publishes the information on the mainline DHT. It gets published on multiple nodes, so if one goes down, it's not a problem. And then if Alice wants to talk to Bob, she looks this information up on the same nodes, because depending on the metric of the DHT, these nodes will be the same. And then you might not get answer from all of them, but that's fine. If you get answer from some of them, you have the information that you need, and you get your data. And we have another mechanism which is based on the old DNS system. We run a DNS server, and Bob can then basically publish the same information as a DNS record to the server, and then Alice can just do the lookup like this, just using basically DNS is one of the things that is never blocked anywhere. So you can do this lookup, and then Alice can find out on which relay Bob is. Okay, demo time. Can you hear the sound?
We're going to run a small echo example.
Yeah, we can.
To show how the connection establishing works. Cargo run accept. So this is the listen side. It starts up, starts listening, and gives us some information we need to connect. And now let's first try it out. Cargo run connect, then a message, hi, and the information we need to connect, and we get the response. So far, so good. Now we want to actually see the information that has been published on the mainline DHT. There's a command line utility called PKARR, and I can use this to resolve, and I get this information, which is just a DNS record. And alternatively, we also have a DNS-based discovery service, and we can query this using dig, DNS command line tool, and there we get exactly the same information. We're going to run a small echo example.
Okay, how do we go to the next slide? Yeah, okay, this demo is from a workshop I've given a few times this year. The last time was at Web3 Summit. So if you are interested and you're a Rust developer, you can just clone this and try it out. And something in general about Iroh and Number Zero, the company that develops Iroh. So everything we do is open source, not just the libraries itself, but also all the support infrastructure. And you can, as I mentioned, you can either use our relays or you can run your own relays. It's just open source code. You can just run it. And you can let us provide infrastructure for you if you have a project which needs global infrastructure, but you don't have to. And we also very much like open standards. We think that many of the peer-to-peer projects in the past have had a problem with trying to boil the ocean, trying to reinvent everything and then getting stuck. So we try to build on open standards as much as possible. So obviously the main thing we build on is Quic, and then TLS, of course, ED keys, and this nice new extension, raw public keys in TLS, and MDNS node discovery for local discovery, and then various emerging standards related to Quic, and PKARR, which is the only standard which is not an IETF standard. But it is good enough for us because it's basically a thin layer on top of the mainline, which has a decent standardization. Even though it would be nice if we would also have an ITF standard for PKARR. Yeah, and that's it basically.
Thank you, sir. There were already a few questions in the chat from Sev and John, I believe.
So my question basically already got answered because he showed it in the presentation.
Okay.
My questions were, maybe they're obvious, I just wanted to be sure, but you showed some Iroh apps or people using Iroh in their apps, like the Rave thing, etc.
Yeah.
Are those apps, and are the end users in those apps using ed keys as identities?
In most cases, these apps hide the fact that they use Iroh or even peer-to-peer technology. It's like an end-user application which does use Iroh for, like for example, for direct connections. But the user just has a normal like Web 2 kind of account. Or in case of Delta Chat, people get an email account. So basically, we don't yet have any applications where the fact that we're using ED keys as identity is surfaced to the user. But I think that's a good thing because, I mean, if an app uses peer-to-peer technology under the hood, it will in general be more robust and even cheaper to operate for the people. And but of course, if somebody has a use case where they want to surface this, it would be totally cool.
Yeah, I'm mostly obviously asking because we are using them as identities in the end app as well, and so it would be interesting to find out that there are other people in other parts of the internet doing the same thing, but we didn't know it. So in these, if other apps through the Iroh ecosystem do end up using keys as identities, they would end up having some potential compatibility with what we're doing. That's why I was asking. I think my other question, somewhat ignorant, but you mentioned that RFC, and I guess I've mentioned it too. My question was maybe more for our own devs than for you, but we're doing some research to do private data primitives with ed keys, and we're making a noise protocol proof of concept. And so I just wanted to bring that up and ask make sure we actually looked at whether or not Iroh hadn't already solved some of this and we didn't know.
John, I just answered it in Slack for you personally in DM.
Oh, I can also comment on this. So we considered using noise, but we ended up deciding on TLS because if you target enterprise customers or just people that are a little bit conservative, if you say we built this custom encryption based on noise, they will just run away. But if you say we are just using standard TLS, then people will say, yeah, okay, that's checks the box basically. And then that was before that there was this awesome new ITF standard or raw public keys in TLS. And now with raw public keys in TLS, I'm really quite happy about how it works because we are using the gold standard that everybody uses, TLS, but we can still use directly the keys in the connection and we don't have to pretend to have a certificate. I mean, before we had some weird hack where we kind of had some certificate just to make sure that there's something on the connection, but now we can just plug the key in there and it's all good. And so I think the decision to use TLS was right in our case. I mean, if you don't have any customers that are conservative, then using noise might be a good idea. But on the other hand, I mean, TLS works, and why not?
Yeah, I see. Dennis is basically explaining that my question was indeed a bit ignorant and malformed. That's not how you put it to me. That's my interpretation. But yeah, I just wanted to double check while the topic was relevant. Thank you. Did anybody else have questions?
I think that, nope.
Not a question, but I still would really like to have Iroh at some point in the home server because of the whole punching and everything, so people can just run it at home and the router NAT is not a problem anymore. But yeah, it's in the future, maybe.
You made me think of a question actually, which is, you may know that we tried an iteration of our project before the current design, where we tried to use Hyperswarm and Hypercore. Sorry, hold on a second.
So, what was the question?
I think he's about to ask it.
Oh yeah, how does it compare to Hyper?
Sorry, I got distracted here for a moment. I'm back.
Yeah.
The question is that, you know, when we saw the first marketing of when Hole Punch became, you know, their own company and instead of just the Hypercore protocol, some of the narratives were private, you know, never on a server, things like this. And I imagine these are similar narratives to hole punching, and you know, could be said for what you're doing here. But the part that I wanted to ask about specifically is, when you're hole punching directly into people's home devices, isn't this a security concern? Like that, like for example, like if somebody were to build, say, a cam girl website, these cam girls don't want people knowing their home IP or how to find them geographically, this kind of thing. And so they'd need to, any application would need to take special care, because now they're hole punching directly in. Am I understanding this all correctly? Or
oh, yeah, that's perfectly correct. It's exactly the same as if you you use DIN DNS or something and open a port in your router. Basically, once you open an Arrow endpoint on your site, everybody in the world can dial you. But then on the other hand, if you have an application that, for example, connects to some backend server of a company, you also have the same situation, because you have to trust the application which runs on your local device to not do something bad controlled by the company. So I don't think it makes such a big difference, but yet it is definitely there is some.
It's the same value that like a VPN brings, right? Like it creates a middleman entity for the data, and so that's how VPNs provide you with more access. And the same is true of servers, and so there is actually a benefit to servers acting as middlemen, despite being able to see too much in some contexts. Yeah, anyway, this is a side topic.
Yeah. And the comparison to Hole Punch, I would say there's one big difference, is that I think Hole Punch is very much a JavaScript library, and we are Arrow is a Rust library, which is meant to be very small, so it can be embedded into mobile applications without causing too much trouble. That's one difference. And then the other difference is we are not as pure in our peer-to-peer ambitions. So Hole Punch has this approach that they use, they have a Hyperswarm DHT, and they use other nodes of the Hyperswarm DHT to help with the hole punching. So basically any node in the Hyperswarm DHT can act as a relay to help other nodes hole punching. And that is a very principled approach. It means that you don't need any servers, but it means that if this other node that is intended to help you with hole punching is on a mobile device or is in some way limited, then that might influence the hole punching rates. So what we decided is, so we're going to be like 85% peer-to-peer. We're going to have relays, and these relays run somewhere in a data center. And you use these relays, which we know are well connected to the rest of the internet, to help with the hole punching. It's not like a centralized system or anything. Everybody can run their own relays, but it's not fully peer-to-peer. We have two different parts of the system. We got the Arrow nodes itself, and we got the relay server. So that's
I think an ideal system supports the whole spectrum, right? Like you want to be able to have people do peer-to-peer things if they need to or when they need to, but you also want to be able to take advantage of scale when